Greetings. This is probably one of the most important podcasts that you will watch in my class. It is important that you pay close attention. It is important that you follow the rules of dimensional analysis. And it is important to me that you don't end up like Jane. Ask me about Jane later. I'll tell you about it in class. So, there are many ways to solve these problems, but it's important that you solve it this way. Because when problems in chemistry become more and more complicated, it will be better for you to establish this basis, to do easy problems this way, and then the complex problems will really not be that difficult. So, stay with me. Dimensional analysis is the way to go. This is what you want to do if you want to be popular, if you want to be considered smart, if you want to be at the top of your game. Dimensional analysis. All right, let's do this. All right, first of all, I've already circled and underlined some of the important aspects here. Pause and write the rules. And now, let's talk about them. All the numbers that you write in dimensional analysis will be written as fractions. You must write all of the units, always. You must arrange the conversion factors in such a way that units cancel. Units cancel diagonally. The numbers on the top of my railroad tracks are always multiplied. The numbers at the bottom are always divided. If you do this, you will succeed. All right, so these are the metric prefixes that you guys need to be aware of. The most important ones are as follows. There's a ton of them in here, but you need to be familiar with kilo, knowing that it's the factor that you multiply by is 10 to the third. It is equivalent to 1,000. So a kilo anything, kilogram, kilomole, kilometer, kiloliter, anything is the same. It's 1,000. There are 1,000 of the base units in each kilo. The other one that you should be very familiar with is centi. Centi is equivalent to 10 to the negative 2, 0.01. So a centi is 1/100th of the base unit, 1/100th of a meter, 1/100th of a gram, 1/100th of a liter, whatever the base unit is. Milli is equivalent to 1,000ths. So 0.001, which is equivalent to 1,000ths, which is equal to 10 to the negative 3. Micro is 10 to the negative 6. So 0.000.001. That is equivalent to a micro. So when I use any of these units that I'm talking about, you should be able to write the conversion factor for each one of those units. All right, these are some other conversion factors. You may want to go back to these conversion factors to refer to these conversion factors as you're working problems. Let us begin with the following problem. I want to convert 85 kilograms to grams. So, the first thing I'm going to do is I'm going to draw a railroad track. And on top of this railroad track, I'm going to start out with the number that is given, 85 kilograms. I draw my tracks, and I'm going to put this over 1 because all numbers will be represented as a fraction according to the rules. Now, I'm going to remember that I want to be able to cancel out the units that I do not want, and the units that I want are going to be placed at the top. So I want grams here. So I work with the units first, and then I'm going to write kilograms down here. And if I remember correctly, 1 kilogram equals 1,000 or 10 to the third grams. 85 kilograms is equivalent, or 85 kilograms is going to be times 10 to the third grams over 1 kilogram. Let's see if this works. Kilograms cancel, and I'm going to go ahead and multiply 85 times 10 to the third, or 85 times 1,000, which is it's the same thing, and that's going to give me 85,000 grams. All right, so we know that that's the correct answer. The next step is for you to box in your answers. I want you, every answer that you get, to box it in. All right, let's move to the next problem. I want to convert 0.0087 milliliters to liters. If you know how to do this, pause now, solve the problem, and then come back and see if you have the right answer. Again, I'm going to draw railroad tracks, and I'm going to start out with what I know. 0.0085 milliliters. And I want to draw my railroad tracks. I want to go to liters, and I want milliliters to cancel out because that's what I do not want. All right, 1 liter is equivalent to 1,000 milliliters. So I'm going to do 1,000 this time, equal to 1,000 milliliters. And it's going to be equivalent to, milliliters will cancel out for me, and I'm going to end up with, oops, I see the error that I made. This is supposed to be 87. Good thing before we worked it out, I caught that error. 87 milliliters. And since this is at the bottom, we're going to divide. So 0.00, plug it into your calculator, 87 divided by 1,000 is equivalent to 8.7 times 10 to the negative 6. And what are my units? Liters. And I'm going to box in my answers and move along. All right, here it is. This is the correct answer. All right, my next problem is I'm going to convert 3.5 millimoles to mole. And you say, wait a minute, I don't know any millimoles. Yes, you do. Anything is 1,000th of the base unit. What's the base unit here? The mole. Millimole is 1,000. There are 1,000 millimoles in 1 mole. So let's start with our problem. 3.5 millimoles railroad tracks. I want to get to moles, and I want to get rid of millimoles. And I know that 1 mole contains 1,000 moles, or 10 to the third. You can write either one. Let's do 10 to the third. That's equal to 1,000. So I am dividing because it is at the bottom. And of course, I don't need to do anything with the 1 because you know anything multiplied by 1 is equal to that number. So if I say 3.5 millimoles times 1 mole, that's equivalent 3.5, the same, then divide. So 3.5 divided by 10 to the third, or divided by 1,000, is going to be equivalent to 0.0035, or 3.5 times 10 to the negative third moles. How do I know it's moles? Millimoles cancels. We are left with moles. Box in your answer, and you have to do a better job boxing your answer than I just did, and you're all set. All right. I want you to try this problem. Now we can go back to the chart that we had for conversions. Well, we know that the conversion between yards to feet. So we're going to say, I'm going to start out with 12 yards. And now I'm going to get you used to one more thing here. I want you to write down question mark. Where am I going? I'm looking for feet. So let's start with that. And go ahead and write your railroad tracks. Yards to feet. Yards. We know a conversion between yards and feet. What do we know? We know that 1 yard is equal to 3 feet. So I'm going to take this and turn it into a fraction, and I'm going to say yards. What do I want? Feet. And I'm going to use these numbers here. 3 feet is equivalent to 1 yard. Yards will cancel, so therefore I'm going to say that the answer here is 12 times 3 equals 36 feet. That is my final answer. All right, let's try another one. I want to convert grams to pounds. So the first thing I'm going to have to do is I'm going to go backtrack a little bit and find out what's the conversion between grams and feet. So moving back, let's take a look at a conversion between grams and pounds. Did I say feet? No, grams and pounds. And we know that 1 pound is equivalent to 436. There it is, 436. So we can say 400. Guys, I'm extremely tired today. I'm not reading the numbers right. 1 pound equals 453 grams. So let's round that up. 454 grams. So let's go back to our problem. So 454, that's my equivalence, 454 grams equals 1 pound. So I'm going to start my problem. 1.5 times 10 to the 5th grams. And where am I going? I'm going to put my question mark. I want to go to pounds. So I'm going to draw my railroad tracks. Grams will be at the bottom because I want to get rid of them. Pounds will be at the top. I'm going to use this conversion. 1 pound equals 450. Well, I believe I did that right because I still don't have my calculator here. I need to go get it. 32 centimeters to feet. Now we have a little problem here because we may not know the conversion from centimeters to feet. So we may be a little confused with what that conversion might be. So I know centimeters to inches, or I can find out by looking at my conversions. Let's go back. Okay. Inches to centimeters, there it is. 2.54 centimeters equals 1 inch. I must go to inches because I don't know a conversion directly from centimeters to feet. So I'm going to go by way of inches to feet. So this requires 2 steps. I'm going to say 32 centimeters. I know that 1 inch is equal to 2.54 centimeters. And now I'm going to draw my railroad tracks, and I'm going to remember to write question mark, I'm looking for feet. That's my final answer, what I would like to see. So I'm going to draw my railroad tracks. I can put a 1 down here, and I'm going to put centimeters over here and inches here, because that's the conversion that I know. And then I'm going to put my numbers. 1 inch equals 2.54 centimeters. That's a point right there. Don't forget that. Okay. And centimeters will cancel out. Centimeters will cancel out, but I'm still at inches, not what I want. I want feet. And I'll put inches here. And do I know a conversion between feet and inches? Absolutely. I know that 1 foot is equivalent to 12 inches. So in this particular case, notice that we don't have to multiply times 1, because anything multiplied times 1 is that same number. So I'm going to skip that step, and I'm simply going to say, punch into my calculator, 32 centimeters divided by 2.54 divided by 12 inches is going to give me the correct answer. So you go ahead and figure that out, and in a moment I will tell you what that is. 32 divided by 2.54 divided by 12 is equal to 1.09. Is that correct? 1 point, and my calculator says 1.0498688. However, I'm not going to round to that. I'm not going to have all those numbers. I'm going to round to 1.0 feet. Okay, box in your answer, and you are done. Excellent. And notice that I'm rounding to the correct number of significant figures of my initial number. Everything else is considered a definition. All right. That's it. There are other problems that I want you to try. I want you to try this one, inches to miles. I'm going to give you a little hint here. You must also go from inches, you must go to feet. Then go ahead to miles. Go ahead, pause, and try this problem. All right? Question mark. What am I looking for? Miles. 5.5 times 10 to the 5th inches. Draw my railroad tracks. And I know that I need to go to feet. So I'm going to put inches down here because I wanted to cancel diagonally. Feet up here. What is my conversion between feet and inches? I know that 1 foot is equivalent to 12 inches. And then I also know that I am not there yet, so I'm going to have to go back here and figure out how many feet in a mile. So back to my chart. 5,280 feet to a mile. So I'm going to go back. 5280 feet is equal to 1 mile. And now inches cancel, inches cancel. Feet will be here. I want to end up with miles, so miles in the numerator. 1 mile equals to 5280 feet. Feet cancel, miles are left. All right, so 5.5 EE to the fifth divided by 12 divided by 5280, and my answer is 8.6. Times 10 to the 0. And since there are two significant figures here in my initial number, I'm going to end up with 8.6, and my units are miles. All right. So I'm going to give you 2 more problems, and we can discuss answers in class. See if you can, well, maybe 1 problem. See if you can do this one. Okay. The end. See you tomorrow in class.